In this lecture, we will discuss how to draw transition state. Let us consider some substitution reaction. We have to draw the transition state for this reaction. Whenever we have to draw the transition state, we have to look for which bond has broken and which bond has formed. So in this case, carbon-chlorine bond has broken. So this bond has broken. Carbon-oxygen bond that is formed. So what is actually happening here? So this oxygen will attack on this carbon and this chlorine will leave. So in the middle, this carbon-chlorine bond is slightly broken and carbon-oxygen bond is slightly formed. Finally, chlorine leaves with a negative charge, so in transition state will have some negative charge. Finally, oxygen has no negative charge, so this negative charge is reducing, so it will have some negative charge. So this is the transition state. Let us consider this reaction. Let us call this as 2. We have to draw the transition state. In this case, carbon-chlorine bond has broken. So what we can do, we can shift this bond this side. So in transition state, this bond will be slightly broken. Chlorine will develop a negative charge. This is because finally it has a negative charge. Carbon will develop a positive charge because it is finally having a positive charge. So this is the transition state. If the carbocation formed in the first step react with Cn minus, it forms this. We have to draw the transition state. So in this case, carbon-carbon bond has formed. So this bond has formed. So in transition state, this bond is partially formed. This carbon will have delta plus charge and this carbon will have delta minus charge. Because some minus charge is neutralized, some plus charge is also neutralized. So this is a case of substitution reaction. The first one is SN2, one step reaction. And the second one is SN1, two step reaction. So first step bond breaking and the second step bond formation. So SN1 reaction has two transition state. Now let us discuss addition reaction. If I have an alkene, this reacts with electrophile. This gives this intermediate. We have to write down the transition state. Now you see the changes. This pi bond has broken and this carbon electrophile bond has formed. So what is happening actually? This pi electron cloud is shifting towards electrophile. So in transition state, carbon electrophile bond is partially formed and carbon-carbon bond is slightly broken. Electrophile will have delta plus charge, and since this carbon is losing electrons, so it will have delta plus charge. So this is the transition state. This is basically first step of addition reaction. So this is first transition state. In the second step, carbocation formed is attacked by nucleophile. This reacts with nucleophile and it gives addition product. So in this case we can write transition state. You see the changes. Carbon nucleophile bond has formed. So what is happening actually? This nucleophile is attacking on this carbon. So carbon nucleophile bond formation is partial. Some positive charge is neutralized by negative charge of nucleophile and some negative charge is also neutralized, so it will have some delta minus charge. So this is transition state 2. So addition reaction involves two steps. This is first step, this is second step. First step is addition of electrophile. Second step, addition of nucleophile. Name of reaction is given on the basis of first step. So this is electrophilic addition reaction. Now let us consider elimination reaction. Consider this reaction. Now this is an example of elimination reaction, and this reaction happens in one step. So we have to see the changes. Basically there is a nitrogen hydrogen bond has formed. A carbon carbon pi bond has formed. A carbon hydrogen bond has broken, and a carbon chlorine bond has broken. We have to save all the changes in one step. So what is happening actually? So this nitrogen is pulling this proton, this is going here, and this is leaving. So there is a bond formation between nitrogen and hydrogen. This bond is slightly broken, and there is a bond formation between nitrogen and hydrogen. One lone pair is used in bond formation. We will have still one lone pair. This carbon carbon bond, a pi bond, is start forming. And this carbon chlorine bond is slightly broken. Now let us see the charges. Nitrogen is losing some negative charge because it is forming bond with hydrogen. This chlorine, because it is taking some electrons, so it will have some negative charge. So nitrogen and chlorine will have negative charge. So this is the transition state. This kind of reaction that happens in one step is called elimination bimolecular. That is E2 reaction. We also have a next kind of elimination that is called E1 elimination. That happens in two steps. First step is formation of carbocation. So in this step we can draw the transition state. This bond is slightly broken. Chlorine will have negative charge. Carbon will have positive charge. So this is the transition state. In the next step, this carbocation formed in the first step reacts with a base to give alkene. We can draw the transition state. You see the changes. This pi bond has formed. H2O is also a side product. Carbon hydrogen bond has broken. So in transition state, we can start making a bond between oxygen and hydrogen because we have a bond formed between oxygen and hydrogen. This bond is slightly broken and there is a pi bond formation starts. So oxygen is losing some negative charge. This carbon will also lose some positive charge. So this will be the transition state. So we have two kind of elimination, E1 and E2. E1 consists two steps, that is two transition state. E2 consists of one step, that is one transition state. Now let us consider next electrophilic aromatic substitution. So you have to draw the transition state for this reaction. You see what are the changes that is taking place. Carbon electrophile bond has formed. Carbon-carbon pi bond has broken. So this pi electron is shifting towards electrophile. So in transition state, this bond is broken and carbon electrophile bond has formed. Now there is a loss of electron at this carbon, so it will have some plus charge. Electrophile is gaining some electrons, so it will lose positive charge. So it has delta plus charge. So this is the transition state. Electrophilic aromatic substitution also involves two steps. This is the first step. this carbocation formed, this is called erinium ion basically. Loses H plus. So in this case again we can draw the transition state. This carbon hydrogen bond has broken and this pi bond has formed. So basically what is happening here? This bond is shifting here. So in transition state we will have this bond is slightly broken and this bond is slightly formed. Hydrogen will gain some positive charge because this bond is shifting this side and this positive charge is neutralized. So this is the transition state. So electrophilic aromatic substitution also has two transition state. Similarly, let us discuss about nucleophilic substitution on benzene ring, that is nucleophilic aromatic substitution. Let us say we have this compound. So in this case again we can draw the transition state. What is happening here? So oxygen attacks on this carbon and this pi bond come this side. So in transition state this oxygen carbon bond is slightly formed. And this bond is broken. This carbon will get some negative charge and this oxygen will lose some negative charge. So this is the transition state. Nucleophilic aromatic substitution also involves two steps. This is first step. In the second step, a Cl minus is lost. So finally we will have a substitution product. So we have to draw the transition state. So this electron cloud is pushing and this Cl goes. So transition state we will have this carbon chlorine bond is broken. and this bond is partially formed. This will lose negative charge. Chlorine will gain some negative charge. So this is the transition state 2. So this is one way for nucleophilic aromatic substitution. It has two transition states. There is another way by which nucleophilic aromatic substitution can occur, that is called Benzene Mechanism. This intermediate is called benzene. So we have tried transition state. So if you see, this is happening in this reaction. So nitrogen hydrogen bond is partially formed. This carbon carbon bond is partially formed. Carbon carbon bond is partially broken. Chlorine will have some negative charge. This nitrogen will lose some negative charge. So this is the transition state. So this is first transition state. In the next step, NH2 minus attacks on this benzene. To give this product. So this is happening in this case. So nitrogen carbon bond is formed. So there is a partial bond formation between nitrogen carbon. This bond is slightly broken. This carbon will have some negative charge. Nitrogen will lose some negative charge. So this is transition state 2. Finally, this product gains a proton to give the final product. It takes H plus from ammonia . This is simply acid-base reaction. So last step is acid-base reaction. So mainly we will have benzene intermediate having two transition state. Even if I have other kind of nucleophilic aromatic substitution that also has two transition state. So in this lecture we discussed how to draw transition state. Once you know how to flow the arrow, you can clearly write down the transition state, because flow of arrow is bond formation and bond breaking.